The tiny island of Bermuda is over 600 miles from the nearest dry land, which makes it the perfect launching point for this leg of my search. This morning, I'm headed out to sea to check out a remarkably simple way to reduce global CO2 levels.
Welcome aboard.
Thank you.
It turns out the key to this big fix might be one of the smallest creatures on Earth: plankton. Tiny plants gulping huge amounts of carbon dioxide out of the sky. Dr. Michael Lomas works at the Bermuda Institute of Ocean Sciences.
This is your toy.
Yeah, this is it.
He's trying to understand how the chemistry of the ocean works.
Something's driving the entire system to a much higher CO2.
I got news for you. There's something's you and me.
Could be.
We're dumping tons of CO2 into the atmosphere. And phytoplankton is sucking about 1/3 of it up. And they dwarf any forest. Algae can be found on almost 70% of the Earth's surface. A simple organism, and lock it away forever like Gary's CO2 pipeline. And the best part is, it's happening right now.
So this is the real-time readout of that CTD sensor that's in the water. The green line is actually a proxy for phytoplankton biomass. And you can see that there's actually a spike here, somewhere around 60 meters.
CO2 is pulled out of the air by plankton living just below the surface. When they die, they sink to the bottom, taking the captured carbon with them, where it will remain for thousands of years. It's a massive carbon pipeline to the bottom of the ocean.
So we're going to actually deploy now our plankton net so we can actually catch some of those animals.
But can we make this plankton work harder for us?
So there it goes, it's in the water.
Well, if we know that the phytoplankton and plants are down there doing their job, is there a way to actually manually go in there and tweak their population and increase the amount of plants in the ocean?
Well, there's a number of things we can potentially try.
In some regions of the ocean, algae need iron to grow and multiply. One idea: feed them. In 2002, this group set out for the coast of Antarctica to see if they could supercharge algae growth by adding iron. They spread tons of iron dust across almost 20 square miles of barren ocean. The fertilization experiment was a success. Within a few days, the sea turned green with plant life.
Each net has a different mesh size. This one's a 200 micron. So that's, twice the thickness of a human hair.
And you're telling me that these little organisms right here in this jar could help save the world?
Absolutely. This sort of greenish-brown layer that's floating to the top in this sample, those are all the single-cell plants in the ocean that conduct photosynthesis every day, and potentially, if they were to sink to the deep ocean, would remove that carbon and take that carbon right out of the atmosphere.
It's the simplest idea I've heard yet.
Ladies and gentlemen, boys and girls of the world, meet your savior.
But this isn't like fertilizing your front lawn. We're talking about millions of square miles of ocean. Sequestering gigatons more carbon with microscopic plants isn't going to be easy. We'd need a fleet of ships crisscrossing the planet, systematically spreading iron over vast areas of ocean. The goal is to produce carbon-hungry algae blooms thousands of miles wide. Hold on a second here. This is starting to sound like a giant biochemistry experiment gone amok. Is ocean iron fertilization really the way to reduce global warming? Let's look at the pros and cons. We've proven we can grow more phytoplankton, and we know we can do it relatively cheaply with iron. But this is risky business. Dead algae may sink carbon to the bottom of the ocean. but it can also starve marine life of oxygen. And there's no way to know how much carbon is actually being sequestered. So, is it worth taking the chance? Dr. Lomas doesn't think so.
We don't understand how all of those things interconnect to give us the ecosystem we observe at any point in time.
Right.
There's a lot going on and a lot of interactions that we think we understand, but clearly don't understand as well as we need to.
Ocean iron fertilization may seem like a simpler way to cool the Earth. But letting the genie out of this bottle might be a big mistake. Meanwhile, almost 800 miles to the north, the clock is still ticking. The waters around Manhattan have risen about 15 inches since the start of the Industrial Revolution. New York City is already dealing with the threat of rising sea levels. But outside the city limits, people are finding solutions that are a little more down to earth. Nestled in the mountains of West Virginia, there's a man who's sequestering carbon before it ever leaves the ground.
Hey, Sean Riley.
Hey, how you doing?
How you doing? What brings you to the farm?
I came to see you. Get out of here.
Josh Fry is a chicken farmer.
Chickens is my life. Sean, here's some plastic boots for...
Now, when you think of greenhouse gases, power production and automobiles come to mind as the two main offenders. But I bet you didn't know, chickens are right up there too.
That is a lot of chickens.
That's 30,000 chickens that you're looking at.
Okay, not just chickens. Livestock constitutes nearly 20% of all global emissions. Josh has found a way to keep his carbon out of the atmosphere. But I'm warning you, it's messy business.
What do these chickens do mostly all day?
They eat and poop all day long. That's it.
It all adds up to a funky-smelling situation. Josh has figured out how to transform this mess from a problem into a solution.
This is my contraption. This is a fixed bed gasifier where I cook the poop into carbon.
Cook poop? What is this guy talking about?
It really is a simple process.
Here's how it works. A chicken poops on a chicken farm. As soon as it hits the ground, it begins to decompose and release greenhouse gases into the atmosphere. But if you take that manure and cook it slowly in a gasifier, you get two things: hot gas and a charcoal called biochar. This biochar locks carbon away, keeping it out of the atmosphere for hundreds, maybe thousands of years.
Can we fire it up?
It's fired up.
All right, let's go. So this is the brain.
This is the brain.
Okay, starting up.
For Josh, burning manure means free heat.
Look at all this. This is not what you would normally find in a chicken farm.
Not normally, no. I'm a high-tech redneck. Yeah.
But it's the biochar Josh is making that could help cool the planet.
All right, Josh, here it comes.
And it might just make Josh Fry a richer man in the process.
Stuff, huh? This is biochar. Black gold, the new black gold.
It turns out all that fixed carbon works as a super fertilizer, too. Josh is currently coming up with a business plan to sell his 9,000 pound a day yield. Look for Fryochar soon at your local garden center or home improvement store.
You think maybe that could save the world?
It will help save the world, yes, in conjunction with other things.
Biochar shows a lot of promise, but it could take a long time to go global with this technology, and it would be costly. Josh's rig came with a price tag of about $1 million. And we can't reduce emissions from power plants or cars with biochar. I still haven't found the silver bullet to fix the Earth. Next stop, San Francisco. There's an atmospheric scientist on the West Coast who has a completely mind-blowing new way to cool the planet. Total carbon dioxide emitted to get me there. over 10 tons. Hopefully, this will be the answer to all of our problems.
It's certainly good to deploy all this new technology, but it's not going to be enough.
Ken Caldera has been studying climate change for almost 25 years.
Somewhere in the world, a coal-fired power plant is being built at a rate of at least one a week.
So there's more to come.
He's got a pretty major news bulletin for me. It may be too late to save the planet by reducing CO2, but there is hope.
We don't have a better way of cooling the planet, but we do have a different way of cooling the planet, a way that's completely different from greenhouse gas emissions reduction, a way that can cool the planet very quickly.
Okay. So how is this different?
Let's imagine that this garden here is our world. The gases in the atmosphere create the greenhouse effect that we've all heard about.
Okay, that paints a picture.
The problem is that we've been putting more greenhouse gases in the atmosphere, and that's a little bit like closing the windows on the greenhouse and keeping that energy in, making the greenhouse hotter.
So what's the alternative?
If we think of a car parked in the sun, which is more or less the same thing as a greenhouse, one thing that we could do quickly is to put one of these shiny reflective things in the window, and that will reflect sunlight away from the car and cool the interior right away. And we can do the same thing with our planet.
So you're saying there's a way for us to reflect some of the sunlight before it even makes it into the greenhouse?
That's right, exactly.
Wow. Blocking the sun to keep the planet from heating up in the first place. This is a game changer.